Hi, this is Merlin and Jay. Today I'm just gonna talk about what I learned today. Um, Actually, the reason why I'm taking like the video that I not that I'm not used to it. What I'm not used to is because I normally take a video with this laptop, and but the reason why I use like different method of it is because the reason why is I didn't take the video yesterday. So that is kind of punishment to me. I really have to take a video and I have to explain what I learned today every day, and that's my routine. But I forgot. I was lazy, so I'm just gonna post it myself, explain the key thing. So today the main topic is authentication. So there's authentication system. Today we are just gonna talk about the OAuth. So why do we need some kind of OAuth and whatever those kind of authentication system? The reason why it is first of all, you know, there are lots of authentication system and there are trade-offs of it, and you have to know some kind of like the um, basic flow and how it goes. So let me just try to talk about the OAuth. Um, to understand OAuth, you have to understand about access token or reference token. So access token is basically means that it's just the tokens with a JWT. It's just a cryptonized value string, and that is the token value is for the accessing some kind of using some specific API. Example, there will be some kind of API, but that's for only the member of it. Example, um, I want I want to look my account. I want to get my information of my account, and that has to be um, there has to be my um, my information has to be stored in the server's DB. That also means that if it's not, they have to validate. So these API to get my information, that has to be protected, because if the member is not logged in, if they're not registered, the API is not gonna be work, and they also this API has to be secured because the getting my information or users information, it's gonna be it's, if you open it, it's gonna be really the security issue of it. So that is why we need some kind of access token or reference token. So to recap, access token is just the tokens, just the token before for the getting some kind of value via API, but these API need to be protected. So you put the tokens on the header of it. The on the header is gonna be like bearer or blah 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 and whatever. So this is kind of access token of it. Next thing is refresh token. So what is refresh token? Refresh token is just the token that refreshes, because your access tokens it's gonna be expired. I don't know what's the upwards of expiration time of it because I'm not the server engineer, but I'm pretty sure the refresh token and access token, and there should be expiration time. As as an example, if I am a server engineer, I maybe put as a token like 30 minutes, but I don't know what exactly. If I put a 30 minutes, and that and if this 30 minutes already expired, the client for the engineer don't know what to do. So what they do is they use refresh token for get the new access token. So server just reads the refresh tokens, and if this refresh token is valid, it sends back the new access token for it. It's very simple. My access token is already outdated, and just give me new access token, or give you a refresh token. So, and normally we put refresh token in the cookie of it. But why? Because if you look the HTTP, the protocol, if you look at the protocol and give some kind of request, the cookie is always set at the header. So the client don't have to care about the cookies, but the cookies value, those kind of thing. Just this client just have to send send it to the server, because the refresh token is automatically storing the header because it's stored as a cookie of it. So let me give you just a diagram of it. Example, there should be client and there should be server. When the client requests some kind of access token with the value, it receives some kind of new data. But if access token is outdated, you see it's gonna be say invalid. So if it's get the refresh token, then we go to the access token. Wait, hold on, I'm just gonna try to draw some diagram. So this is it. I don't know if you guys can see or not. If you look at here, the client, we're gonna send access token, the version of it. Of course, the server, we're gonna check the access token. If it is valid, we're just gonna respond if it is some kind of data. And next, if access token being sent, and that is gonna be if it is expired, of course server engineer will not give data. So clients has to be use refresh token to get the new access token, refresh token to get new access token. So that's kind of really simple process of it. So there's a really simplified version of it. But let me say, let me focus on the client side more, because I'm a front-end engineer. So let's see your client and server. You got access token, because normally refresh token is stored in the cookie. If it is HTTP only, the JavaScript cannot get the value of the cookie. So you only get manipulate the access token value. The first choice is to store it in the local storage. But the bad thing is that everyone can see it. That's gonna be security issue of it, and that's very simple. That's no engineering, and that's gonna be security. I don't think that's a very good idea. So the second option is using the React hook. You can just use React, just global storage using Redux or Jotai, whatever, and you can just validate it using use effect. But the problem is that, example, I'm just gonna give it. There we go. So you stored some kind of like global variable, global state. I'm just gonna draw a thing. I'm stuck in here, and use the effect hook. We're just gonna call API that core API or whatever. So if you look at like global state here, there's gonna be access token. But use effect has to be to check this is valid or not. The why? Because there should be some page has to be protected. If users already log in, that has to be goes to some kind of page. But if user didn't log in, it should be blocked. Some pages should be blocked. So we commonly use effect hook on it. My bad thing is it really like fetching API calls and fetching access token logic is really heavily rely on these hooks. I know these hooks could be really nice, but the bad thing is it's really out of my hand. The React hooks is really hard to manage, because you have to think about like dependency in the use effect. You have to think about the API calls of the inside use effect, because and if there is if it is not valid, you have to put some kind of call refresh token like logic in the use effect, and there's gonna be so much boilerplate. So my other strategy is using worker thread. So what is worker thread? If you look at the browser of it, there's a main thread and there's worker thread, web worker. So worker thread is just the helper thread rather than just the combining thread, because JavaScript is just the single threaded language. So the web worker thread is not just the combination of the thread. It's just helper thread, not just the real like the thread thing. But whatever. And Oh, I'm just gonna try to explain more about this. If you look at the browser, it just kind of CS part of it. Like because I just talk about like thread thing, the browser, like the main thread or single thread. If you look at the browser, you should understand browser is just an application, just a program. When you click the program and when you execute the program, it's gonna be processed. The program is just kind of static thing. If you run the program, that's gonna process. It's just the instance of the program, but there's gonna be a running. So process is not some kind of like magic thing. The process is it's just the object. That is an object, but that has so much resource of it. The operating system sends resource to the process when a process needs some kind of resource. For example, the process might need the stack. It's gonna be stack, but also whatever heap or whatever stack, and I think also the code of the process. And the reason why the process is object, the process, and also it gets the resources from the operating system. It has to be stored in some kind of data structure, which is called the PCB, the process control block. It's just the data structure in the process, but in a wide term. What do you mean wide term? Because if you look at the PCB, there is a program counter, and what else? I think it was some kind of program counter, like it was related to about hardware stuff. I forgot it. Yeah, well, whatever, program counter, whatever. But in program, wait, hold on. Yeah, so there's gonna be stack of it. Or that could not. I'm not sure. There's also gonna heap. There should be heap of it. PC. What else? I think there's more of it, but whatever. And the reason why I say wide term because the PC is actually just a register of it. Register? Yeah, it's a register. Program counter is just a register. PC is also part of the IP, instruction pointer register. So it's just it's just a register. Register just stores in the CPU processor, because processor can store some kind of value inside their storage, because processor has some kind of, it's just a brain of the computer, but it's stored some kind of logic on it, and the register just the work as a storage, but not just static storage. It could divide the two of it. General purpose of the register, special purpose of the register. We normally use the special purpose of the register if there's like huge logic of it. Example, program counter, the instruction pointer register is known as the special purpose of the register. But why we have to different of the PC IP into some kind of special purpose of the register? Because this register is really special that relate to the fetch cycle. The processor just only execute one instruction. The instructions just the bunch of assembly, just a per line of it. So there's the instructions, and processor can only execute one instruction per time. So, but if there's a lot of 20 lines of the instructions, it has to be stored in the memory of it. And when you store in the memory, after running this instruction, it has to be get next memory, and which is called fetch. And next, when you get the next memory, it has to be decoded, because to put the memory of to put this value in some specific memory, it has to be like encoded. It has to shrink it, and it has to combine it to byte or whatever. And we call the decode process, and next and then we execute. And so that is kind of simplified explanation of fetch cycle. CPU fetch, decode, and execute. That's all of it. And so to back again, We use PCIP for these fetch because PC is just program counter. There's no big like there's no hard thing of it. Okay, you put there's a 1, 2, 3, 4, 5, 6, 7, 8 instruction, and in CPU execute one instruction per time, and so the 9 instructions gonna be stored in the memory, like bottom to top or top to bottom, whatever. And the PC just like increasing the offset, the pointer of the memory, because after the executing the number 2 instruction, and you have to go to the pointer 3 instruction, program counter work just like helps those kind of thing, and that's how it works. And also, and that's why we call it a special purpose register. There's kind of little big logic of it. So to back again, we talk about PCB that has the program counter, stack or heap, and that is why I say wide range of data structure, because we commonly imagine of the data structure of the stack or heap, but PCB known as a wide range of the data structure. And now I talk about the program counter and static. That is static, and the program is a static, and processor is just like dynamic, but that's running. And process has a execute thing. The process can divide into resource grouping and execution. Resource grouping is what I said, the PCB those kind of thing. But execution is the one who doing is the thread. Thread is just the one who executing. So which means that process just has to be the minimal the one thread. It's just a thread. So thread, and the interesting about thread inside the process is the thread is inside of the process, which means that it shares the resource of it. Here, it shares the resource of it, and that is why we just say that the single threaded, the multi-threaded, and that's cool kind of thing. Single threaded is just one thread. And JavaScript, the browser is actually not single thread. So what do you mean by that? Browser is an app. When you click the app or program, it's gonna be processed. But browser is multi-process, which means that there's a bunch of this. In the browser process, in the browser, in the Google Chrome, there's a browser process, and there's render process. I think there's more, but I think I forgot it. But the main thing is browser process. Browser process do a lot of stuff, because like network calls using network thread, and what else? And like UI thread, because UI thread is just the address bar. Because if you look at open the Chrome, you can just click the refresh button, or you can just click enter of it, and that's kind of UI thing, and we call UI thread inside in browser process. And UI thread work as the main thread. And the render process, there's only one thread, which is called main thread. And that is why render process, and that is why JavaScript is called a single thread, because the render process, what it does is it renders the page, it executes the JavaScript, and all of the logic of the JavaScript, parsing or build the HTML logic and renders the web page, is only in the render process, but basically in the main thread. And JavaScript, the reason why JavaScript single thread is just because of this kind of environment of it. JavaScript single thread, it's because of environment. JavaScript is just a language. There's no JavaScript except single thread. It is nonsense. JavaScript is just the environment, is just the single thread. The execution, the environment is single thread. So back again. But JavaScript, back again, we said there's a main thread, but worker threads work just like helper thread, not just like parallel thing. It's just like helping the main thread. Okay, so we just talked about authentication system, but we are now explaining thread, and we just explained the worker thread And now I'm just gonna explain the authentication system using worker thread. And the worker thread is it's just the separate. Because I talk about this thread, they are just like the execution. So what I did was, when I call when I want to get the access token at the first time, after when you first log in, you have to get the access token, right? I use worker thread of it. So I say, I request, and worker thread is the one who gets the request. When it is the one who requests the access token from the server, and server responds to the access token, and worker thread sends the back. And the access token stored in the local variable in the worker thread. So that's kind of in-memory storage. And when you get to the access token, the main thread, what it does is, it doesn't store as a state. It just checks if this access token is null or string. If it is string, or if it is null, just of course it gotta be invalid. It tells rec hooks to go to a login page or landing page. But if it's not invalid, this access token is stored in local storage, but not the value of it, just the boolean value. But if access token is there, just put the true value on the local storage of it. And it has to be, I use Jotai, the library, the state management library, to assist with the local storage. That could be state and also be function of it. And also, I stored this kind of local value, local storage, right? And there's some like good hooks in Jotai, which is called toggle atom storage, which is the toggles this local storage. It's just doing some kind of work in the local storage. Example, if you make some kind of dark mode, light mode, you have to store the current light mode or current view, the color mode inside the local storage, right? But what I just said of the toggle atom local storage is the one who changed the dark or light. That's toggle. But I just look at this kind of hooks in a different way, because I can just say, if it is not valid, I can just use the toggle hooks to refresh the access token, right? So I utilize it using this hook. So all of the logic is stored in the worker thread and main thread. They don't know what to do. So all of the business logic of the authentication is here. So there's no big boilerplate on the main thread, and that's how I did it. So this kind of explains a bit. Yeah. so like this. So this is really how I did those kind of authentication system. I know you shouldn't really use worker thread. I mean, like, you can just use local storage or whatever. But what I really believe of those kind of thing is, I believe this kind of engineering thing is important, because the authentication is very crucial. If you just look at authentication system, just say, well, I can just use putting the local storage. That's very simple, right? But I believe there's always trade-off for a simple solution. So this is it. Have a nice day and see you next time. Bye bye.